You know that feeling, right? When you're woken up in the middle of the night and have to solve some crazy complex problem? That groggy, slow-motion fog? Well, it actually has a name. And in the world of high-tech, it can cost thousands, even tens of thousands of dollars per minute. So today, we're going to dig into how a new kind of AI agent can solve these massive system meltdowns, all while you're still asleep. And it all kicks off with one very specific number.
22. So what's the deal with 22? What could that possibly be? I'll tell you this, it is not a random number. It's a really crucial piece of the puzzle when we're talking about high-stakes, pressure cooker problem solving. Any ideas?
Okay, so it turns out that's the average number of minutes it takes for our brains to fully reboot after being woken up. It's a real thing called sleep inertia. Now imagine a critical system is down. During those 22 minutes, the company is just hemorrhaging money. And that delay, that very human limitation, is exactly what we call the 2 a.m. problem.
So let's set the scene. It's 2 a.m. An alarm is blaring. Your company's website is essentially broken. 90% of your users can't log in. The person who gets that dreaded call? Well, that's the hero of our story today, the Site Reliability Engineer.
So what is a Site Reliability Engineer, or SRE? Well, think of them as the digital world's firefighters. Their whole job is to keep the lights on, to make sure all the systems are running smoothly. So when that 2 a.m. alert hits, they're on the clock, battling not just the tech problem, but their own brain fog, and a financial time bomb that's ticking louder every second.
All right, their mission, should they choose to accept it, is basically a three-part race against the clock. First, what exactly is broken? Is it the login service, the database? Second, why did it break? This is the real detective work, digging through mountains of data. And finally, number 3, how do we fix it? Like, right now. I mean, the pressure is just immense. So it makes you wonder, why don't we just throw some AI at this?
And that question brings us to what seems like the most obvious solution, right? But it's also a deeply flawed one. You've got all this data, so a big, large language model feels like the perfect tool. But, this path can lead you straight into a pretty nasty trap.
I mean, look, it makes sense on the surface, right? These big IT systems are churning out gigabytes of data every single hour. We're talking logs, metrics, traces, the whole shebang. So why not just aim that entire data fire hose straight into an LLM and say, hey, find the problem? Well, there's a really, really good reason why that approach is, well, a disaster.
Welcome to what some folks in the industry call hallucinations city, because that's exactly what happens when you just overwhelm an AI like this. See, LLMs are designed to find patterns and create plausible-sounding sentences. So if you just dump a ton of unrelated noise on them, they'll start, well, making stuff up. They'll confidently fabricate these causal links that don't exist, connecting a random CPU spike from Tuesday with an error log from last month into this perfectly convincing story that is completely 100% false.
And this really gets to the core of the problem. There's a fundamental mismatch in their goals. An LLM wants to predict the next plausible word. It's basically a creative writer. An SRE needs to verify objective facts. They're a forensic investigator. So using a generic LLM for this is kind of like asking a poet to perform an autopsy. The tool just isn't built for the job. We need a totally different way of thinking about this.
So, okay, if the brute force data dump approach is out, what's the alternative? We need something smarter, way more strategic. And this is where a new approach called agentic AI enters the picture. The key isn't throwing more data at the problem, it's about using the right data. And the secret sauce for that is a concept called context curation.
So what is context curation? It basically means we're turning off that data fire hose. Instead, the AI agent behaves like a skilled detective on a case. It strategically picks and chooses only the signals, the clues, that are actually relevant to the specific incident it's looking into. It is all about quality over quantity. So, where does it find these clues? Well, it pulls from what people in the industry call MELT data. That's an acronym for metrics, events, logs, and telemetry. Think of this as all the raw material, all the potential evidence. But again, the real magic isn't in the data itself. It's in how the agent decides which little pieces of that MELT data are worth a closer look.
And the way it does this is actually pretty brilliant. The agent has access to a real-time dependency map. Think of it like a live blueprint of how every single piece of the system is connected to every other piece. So when the login service goes down, it doesn't waste time looking at logs from, say, the billing system. No, it intelligently pulls data only from the things it knows are directly connected, like the user database or a specific authentication service. It's surgical. It's incredibly efficient.
Okay, so the agent has carefully selected its data. What happens next? Well, now it kicks off a systematic investigation loop. It literally starts to think like a human detective, but it does it at the insane speed of a machine. And this process is a classic feedback loop. Step 1, it perceives the environment using that highly relevant curated data. Step 2, it starts to reason. It forms a hypothesis like, I think the problem is that the database is running slow. Step 3, it acts on that hypothesis. It goes out and requests more specific data to prove or disprove its theory, like, show me the database performance metrics from the last 5 minutes. And finally, step 4, it observes the results of that action and refines its thinking. And it just keeps doing this, looping over and over, getting smarter and closer to the real answer with every single pass.
And the output from this loop, this is what makes it so powerful. The agent doesn't just spit out a final answer and say, trust me, no way. It delivers a probable root cause, and it backs it up with all the supporting evidence. It gives you a full, transparent chain of thought, so the human engineer can see exactly how the AI reached its conclusion. And that explainability, that's absolutely crucial for building trust in the system.
But look, finding the problem is really only half the battle, right? The real goal is to get things fixed. And this is where the AI agent shifts gears and becomes this incredible co-pilot for the human SRE, helping them get from what's wrong to it's fixed way, way faster.
It helps out in 4 really concrete ways. First, it helps with validation, giving the engineer a checklist to confirm its diagnosis. Second, it creates a runbook, which is just a step-by-step action plan to actually fix the problem. Third, it can go a step further with automation and actually turn those runbook steps into ready-to-use scripts. And finally, and this is a big one, it handles the documentation, automatically generating those painful post-incident reports. What a time saver.
So let's make this real. Imagine the root cause is something classic, like a server's disk is full, which crashed the database. The AI-generated runbook would give the SRE the exact commands they need to copy and paste. Step 1, archive the old logs. Step 2, restart the database. Step 3, monitor the disk space to make sure the fix worked. It's like having an expert whispering the right answer in your ear, even if you've never touched that part of the system before.
So when you step back and look at the big picture, what does all this mean? Well, it feels like we're stepping into a completely new era for how we run our technology. And it's an era that isn't defined by AI replacing people, but by a really powerful partnership between human experts and intelligent machines. Yeah, this quote really nails it. This whole thing is not about AI taking over anyone's job. It's about AI augmenting human intelligence. The agent does the lightning-fast, needle-in-a-haystack data analysis. And that frees up the human engineer to do what humans do best: apply judgment, make strategic decisions, and oversee the actual fix. And at the end of the day, the bottom line business impact boils down to one key metric: MTTR. That stands for mean time to repair. By basically automating the entire diagnosis phase and prepping the solution, these AI agents can slash that repair time. And that means saving a ton of money, massively reducing stress for the team, and maybe, just maybe, letting our on-call engineers actually get a full night's sleep. But honestly, this is about so much more than just fixing broken stuff faster. It's about fundamentally changing the nature of the job. So I'll leave you with a question to think about. Once we free up our smartest people from this frantic 2 a.m. firefighting, what are the truly big, creative, and innovative challenges we can finally empower them to solve?